Welcome to this Show Me tutorial. This is the first of a small series of tutorials I'm going to be running on the autonomic nervous system. Now, in your practicals you will have been introduced to the general organisation of the nervous system, i.e. the central nervous system and the peripheral nervous system. Now, there is another sub-compartment of the nervous system, particularly of the peripheral nervous system, known as the autonomic nervous system. And there are two components to this, and they are, first of all, the sympathetics and the parasympathetics. And apologies for my rather squeaky stylus. I'm sure that will get more annoying as we progress for both of us. So, we're going to be dealing with the sympathetics and the parasympathetics, and to give us an idea of where the sympathetics and parasympathetics arise from, we need to look at the arrangement of the nuclei of nerve cell bodies that have an autonomic nerve cell function inside the spinal cord. And to do that, we're going to move on and have a look at this diagram. It's not a particularly good diagram, mainly because I drew it, and that probably means it needs some explaining. So what I'm going to do is just label this. Up here, this is the brain, believe it or not, and these are the two cerebrums. You've got the cerebellum down here, and the top, really, what's continuous with the spinal cord below, is a structure called the medulla oblongata. You may have heard of this before. I'm just going to abbreviate that as MO. In here we have the spinal cord. In this region in here we have a kind of swelling which represents the sacral components, and that tapers off to the tail end here of the spinal cord, and that's known as the conus medullaris. So really we go from the medulla oblongata all the way down to the conus medullaris, and that is the extent of our spinal cord. Okay, so we're going to do away with labels, and we're going to look at the representation of autonomics inside the spinal cord. So what we're dealing with here is individual neurons and their nerve cell bodies and where they originate from to give parasympathetic or sympathetic outflow from the spinal cord. So what we're going to do is we're going to build a little key up in this top left hand corner, and the red is going to equal our sympathetics, abbreviate like that, and the green is going to represent our parasympathetics. So first of all, let's deal with the sympathetics. Now, the sympathetics arises from particular segments of the spinal cord, which are from T1 all the way down to L2. That's where you'll find the nerve cell bodies of neurons that have a sympathetic function. So let's draw that on. So we're going to represent that here as a line across here and here. We can colour that in, and that's going to represent an area of the spinal cord where we might expect to find, or we would expect to find, the cell bodies of sympathetic neurons. Now, we're not going to worry too much at this stage as to whereabouts in the spinal cord these neurons reside. We'll have a little closer look at that in the next slide, but for now we just need to know that they exist between T1 and L2. What about the parasympathetic nervous system? Well, that's slightly different. First of all, the brain stem is responsible for some of the parasympathetic outflow, and these are represented by nerves called cranial nerves. And you may have heard of these before. Now, the good news here, certainly on this course, is you don't need to know really what they're called. But it's probably worth knowing that there is 12 of them, and only 4 of them have a parasympathetic function. Okay, so they are numbers 3, 7, 9 and 10. Okay, now these all have names, but the one name we're expecting you to remember is cranial nerve 10, and that's because this is a nerve you're probably going to be able to identify in specimens, and it's probably, I think it's fair to say, all medical students' favourite nerve at some point, and that is the vagus nerve. Okay, so if ever you hear the term cranial nerve 10, you know that that term just means the vagus nerve. The two are interchangeable. So we have 4 of these cranial nerves, 3, 7, 9 and 10, which represent the cranial portion of the parasympathetic outflow. Where does the rest come from? Well, the rest comes from segments down here in the sacral swelling, down here, which we can colour in down here in green. And this is segments S2 to S4. So the parasympathetic system here can sometimes be represented a slightly different way. It can be called as its cranial and sacral parts. So it's sometimes referred to as the craniosacral division or system, which is the same as the parasympathetic nervous system. So that's where we would expect to find our sympathetic nerve cell bodies and our parasympathetic nerve cell bodies representing the autonomic outflow from the spinal cord or the brain. So let's look specifically now at the sympathetic outflow represented by T1 here and L2, and we're going to look at a cross section of the spinal cord here. So before we get on to explaining the position of certain nuclei, we need to just have a quick review of what we're seeing here, or what's represented by the diagram. So this is a cross section, otherwise known as a transverse section of the spinal cord, and what it shows is that what we have is a region which is in the middle.
Subscribe to Soton Brain Hub for more videos to help explain the mysteries of the brain.